All right, so we're gonna start our log unit, and our log unit, y'all, if you'll pay attention, it's not hard, okay? Logs just look like they're crazy, but they're really not that bad. I like teaching logs is one of my favorite things to teach, and rationals, not rational, yeah, rationals. So we'll get to that, I think, next. But the first one, if you guys have calculators, I told the students in here, if you have calculators, you want to go ahead and get them out because we're going to look at these graphs and stuff. So exponentials we've talked about since day one, and we know that they look like kind of the Nike check or whatever. The inverse of an exponential is a log graph. Okay, so they're inverses of each other. So we're going to work with exponentials and then we're going to talk about logs. So we're going to graph exponentials. An exponential equation. Oh yeah, I'm sorry. I do that all the time. I forgot to turn the screen on for them. All right, an exponential equation is any positive r not equal to 1 raised to some r exponent. That doesn't really matter what we're looking at. This is an exponential equation, and we already knew that. All right, so a is going to equal the y-intercept. Now that could change depending on if we have a transformation. And b is your rate of change. In Math 1, you might have heard it called the multiplier. There are two types of exponential equations. There's exponential growth and exponential decay, and you guys have worked with both of those. Growth just means it goes up, decay just means it goes down. What makes it go up and what makes it go down? So exponential growth, I'm going to give you an equation that's kind of like that. So if we had 2 times 3 to the x, this b number right here in the formula, b, if it is greater than 1, you can look at the equation. If that b is greater than 1, then it's going to be growth. If we look at this one, this b number, and not just because it's a fraction, but because it's between 0 and 1. It's not going to be a negative number. It's going to be between 0 and 1. Everybody understand that? Okay. So we're going to classify each of these as growth or decay depending on what we see. So if we look at this one, we have 1/3 in the middle. So what is it going to be? Growth or decay? Decay. Good job. Your next one, again, we're looking at the number in parentheses, the 4. What's that one going to be? Growth, because it's greater than 1. This one's a decimal, but the question is it greater than 1 or is it between 0 and 1? Greater, so that means it is growth. Well, look at this one. This one's kind of weird, isn't it? Why is this one weird?
There's no parentheses.
Yeah, there's no parentheses. What else do you see? A negative x. Okay, so let's look at this. I'm going to graph it to show you what we're looking at. 7 to the negative x. I'm going to zoom 6 so you can see it. Can you tell me what it is? Is it growth or decay?
Decay.
Decay. Tell me why this is decay, but it doesn't have like a 1/3 or a 1/4 or something like that. Anybody know? Think back to unit 1. What do we say made it look different?
Negative x.
The negative x. What does that negative on the x do?
Reflect y.
Reflects y. So we were a growth because we don't have, we don't have that number. It's 7. So we were growth, but then when we put that negative on there and we reflected it over y, it changed us to decay. Everybody see that? So if it has a negative x, it's going to make it decay. All right. So we can transform these functions, which means it moves left or right. All right. A function whose known x is located in the exponent We're gonna talk about the asymptote in a minute. Okay, we're gonna talk about the asymptote in a minute. H is this number with X. It shifts left or right. You guys remember doing transformations, right? Okay, so if that X is positive, we pull it outside and it becomes negative. And a right is going to be a negative with the X. Don't get too lost on that. It's the same exact thing we did in unit 1, okay? So you already know what this is. K shifts, K is the last one. It shifts up or down. If K is positive, it shifts up. If it's negative, it shifts down. All right, if we look at this one, it says change Y. Remember, f of x same as y. So if it changes y, what does it do?
Reflects X.
Perfect. What if it's a negative x? What does it do? Reflect what? Y. Again, all those, that whole little chart right there, you already know. Okay, that's nothing, anything we've done new. All right, so this says to graph this exponential function. We've already graphed it before, but you can use your calculators. Remember, you get your calculator on every part of the test. So I'm going to put the function in. I'm going to look at my table. I have a -1, -2. I have a 0, 1. I have a 113. It's way too big. And then I have some decimals there. Where does this graph go to?
-3.
Yeah, what does it do at -3? Or what does it not?
It don't cross it.
Yeah, it's your asymptote and it doesn't touch. So at -3, and usually that's a dashed line, but I want to make it big enough you can see it. I'll highlight it for you. So remember at -3, it doesn't touch. Then we can graph our coordinates, -1, -2, 0, 1. Sorry, I did that wrong. 0, 1. What was our other one? 113. We can't get that on there, but it's way up here. You can also graph it to make sure that you're graphing it right. Should look like this, and it's going to be pretty steep. I don't need you to graph them for me. You can do it on your calculator. Is everybody okay with that? All right. So if we're looking at our graph, let's answer some of these questions. What is your A? So this is what confuses some people sometimes. This is our original function, okay? Your parent function is going to be whatever your B is just to the X. So your B is 4. What we have right now, if I rewrite this equation, would look like this. Okay, that 4 is your multiplier because it's the one that has the power. So your parent function is whatever that is in parentheses, just to the X power. That's the one that we're going to shift left, right, up, down, reflect. What is your A? What's the number in front of the one with the power? What is the number in front of the number with the power? 1. So if I'm looking at this one, this is our A right here. Our B is the number with the power, B for base. What is your B?
4.
Is this one growth or decay? You can look at the graph. What is it?
Growth.
Growth. Again, why is it growth? It's a 4 for your B. Anything greater than 1 is going to show growth. Transformations. What did I do to this 4 to the X? What's this +1 with the X? Which way did I go? Left, how many?
1.
Perfect. Remember, you do the opposite with the X. On the end, I have a -3. What does that tell us we do? Down.
Down.
That's it. Y-intercept. Y-intercept. Where does it cross the y-axis?
0, 1.
1. If you want to put it as a coordinate, that's perfectly fine as well. It doesn't matter. I usually write it as an equation. The reason I write it as an equation is so that you know that's where it crosses out. Equation of your asymptote. Remember, asymptote is this pink line. How do I write the equation of the asymptote? What axis does it cross? The y-axis. And where does it cross it at? Guys, we've already done this. This is nothing new. All of this is a review of exponentials. We've already done. Domain. How far left? How far right?
Negative infinity, positive infinity.
Perfect. And I just moved it over so my numbers didn't run together. What about your range? How low to how high?
-3 to
Excluded
infinity.
or excluded. What do we got to do? Excluded. So parentheses, -3, all the way up to infinity. And then last unit, we talked about right and left in behavior, right? Yeah? Oh, well, what does this one do? What is the left doing?
It's decreasing.
To where? Try again. -3. So it only goes to -3, right? So if we were doing in behavior, and I don't like this necessarily, this is kind of a little bit over you guys. F of X is going to -3. So on the left, we would go to -3. Now on the right is what you already know. Where's the right side going? Infinity. Any questions on the first page? So probably the hardest part were those last two questions and really just the left behavior rather than the right. All right. We're going to do the same thing for this one. Guys, if you need to graph it, graph it. It's okay. Don't stress out about it, whatever. Remember, your parent function is going to be whatever's inside of the parentheses or whatever is raised to the power. So what is raised to the power? What number is raised to the power?
1/2.
1/2. And then to the X. That is your parent function. Your A is the number in front of that base. What is the number in front of the base now? -1. If we rewrite this, we would have -1 times 1/2 x minus 2 plus 5, so that you know where that -1 is coming from. What about your B? What's the number inside of parentheses? That is your rate of change. Is this growth or decay? We're going to check it out real fast. I'm not real sure. I don't know. -1/2 to the x minus 2 plus 5. We're going to graph it. Is this growth or decay? Growth is going up, right? It's increasing. So this is growth. What makes it look like this and not like a Nike check?
The negative on the outside
Yeah, that negative on the outside does what?
reflects over the X.
So that's one of our transformations. Reflect X. Did we move left to right? Right 2. Did we move up or down? Up. How many? 5. Perfect. Look at your graph. Where's your y-intercept? I'm gonna ask one more time. What's your y-intercept? It's on my graph. 1. Again, you can write it as a coordinate. That's perfectly fine. Equation of the asymptote. So I might have to go on my chart to figure this one out, and that's okay. Let's see. What's happening? What's happening? Where's my asymptote? 5. How do I write it as an equation?
Y equals 5.
Good. Make sure you write it as an equation all the time. So the equation of the asymptote. I'm gonna go back to
Thought
my,
it would be x equals 5.
nope. What axis would that asymptote go through?
Oh,
All right, domain. How far to the left, how far to the right? Negative to positive infinity. Your range, how low to how high?
Negative infinity to 5.
Perfect, and 5 is not included. Left behavior, so as x goes to the left, where does this graph point? This side, negative infinity. On the right side, where does it go to? 5. Good job. Any questions? Is everybody good? All right. So now graph the following functions by making a table of values. We don't know how to work with log functions yet, so it just wants you to take the values and make it inverse. So graph the function, graph the inverse. So I'm going to do both. I'm going to use 2 different colors so you guys can see. All right, so the first one, I'm going to do 5 to the x, and I'm just looking at my table of values. I'm going to go back up. All right. Sorry, y'all. So I have 0, 1. That's my first one. I have 1, 5. 2, 25. I can do more. I'm just going to leave it as that. And I'm going to graph those points and kind of graph this equation. So 0, 1, 1, 5, 2, 25. I'm not going to get on there. I have negative 1 and 0.2. Negative 1, 0.2 would be like right here. Where does it never touch? 0. So there's my asymptote. So it's going to look like this. All right, so we know how to do that one. So here's your inverse. Inverse means we just switch x and y. So inverse. We just switch x and y. Switch x and y. What's my new coordinate? If my coordinate is 0, 1, and I switch x and y, what's my new coordinate? Thank you. Thank you. Next coordinate. It's okay.
5.
5, 1. Be 25, 2. 0.2, negative 1. I'm going to graph those. 1, 0. 5, 1. I can't do 25, 2. I can do negative 1.2. If I keep looking and switching them, 0.04, negative 2. Sorry, 0.2, negative 1 should be like right here. Let's see. Basically zeros. So it's going to look like what? What's it going to look like? What do y'all think? Do we get enough graph? 0.4 and -2. What's it look like? You guys see this crazy graph? Yes, no? It'd be 25 to something way out here. You guys see it? That's how you're doing. That's it. Let me show you. An actual log graph. So if I put in log 2x and I graph it, this is what it looks like. Is that kind of what ours looks like? This bottom part is what we're kind of worried about. We'll check that out in a little bit, okay? We'll do that even more. All right, so look at this one. Log 3 of x. I'm gonna show you how to put it in. You ready? Actually, I'm not. I don't want to do this part at all. We'll get back to it. We can do 2 to the x minus 2. I want to keep it just working with exponentials. 2 to the x minus 2. Make sure you get that minus 2 down there. Look at your table. We have -2, -1.75, -1, -1.5, 0, -1, 1, 0, 2, 2, 3, 6. That's probably about as far as it'll go. So I'm going to graph this. -2, -1.75, -1, -1.5, 0, -1, 2, 2, 3, 6. So where do you think our asymptote's at? -2. So there's your exponential. Inverse your points, -1.75, -2, -1, -1.5. I'm sorry. -1.5, -1, -1, 0, 0, 1, 2, 2 is going to stay the same, and then 6, 3. So -1.75, -2, -1.5, -1, -1, 0, 2, 2, 6, 3. So something like this. And we'll talk about these ending points soon, okay? We'll talk about the ending points soon. Any questions on this? So how do you find the inverse?
Which X and Y?
Which x and y? If you're finding inverse of equations, so it says find the inverse of this equation, you switch the x and the y, and then you solve for y. We're going to talk about that. All right, so we are at your quiz, but we're going to look at this quiz for a minute. This is not a multiple choice quiz. Everybody got it? Not a multiple choice quiz. So all you're doing on the first one, use the following equations to find the y-intercept. So make sure you find the y-intercept. You can graph them or you can find it from the equation and determine if the exponential function is growth or decay. So again, here's an example. Y equals 1/2 times 6 to the x. This number is your y-intercept. This number, if it's greater than 1, it's growth. Watch for negatives. I see 1 on number 4. That's a little tiny negative, so watch on number 4. If it's between 0 and 1, it is decay. That's all you're doing on this one. Okay? Pick out your y-intercept. It's the number in front. Tell me whether it's growth or decay. Remember that our parent function is whatever our base is to the power of x. Okay? Your a is the number in front of the base. If there's not a number there, what number are you choosing? 1. B, you already know what that is. That's your growth factor. Transformations, did it go up, down, left, right? Did it reflect? Y-intercept, we've already talked about. You can find that from the graph. Equation of the asymptote you should know how to do. Domain and range you should know how to do. Watch your left and right in behavior. Okay. It says now make a table of values for the inverse and graph it on the same graph. So you are supposed to graph this function, this one, here. Look at your table of values, switch it, and graph the new function, okay? Graph the inverse. Make sure that you have 2 graphs on here. Make sure that you have tables at the bottom. If you look again, it's the same thing on this one. Does this one have any transformations?
It reflects
Reflects what?
Y.
It reflects Y. So that's the only transformation that it has. I just want you to see that little teeny tiny negative up there. Okay, that's why I pointed that one out. Watch for those little tiny negatives. Does anybody have any questions? You will have to upload this quiz, guys. I'm sorry that I did not give you your notes. It wasn't that I was lazy. We didn't have them together. So I will give them to you on Monday. So try to do this without them. You'll be fine. You can do it on a separate sheet of paper and just turn it in. It's not multiple choice. Okay, so it's all uploading your work. Is everybody good? All right. I have not put your grades for your test in. If you have not taken your test, that needs to be done today.